Hello and welcome to the video lecture on indexed file organization. So this is the second type, the second more advanced file organization than just the sequential file. So what we have here is we're going to start talking about indexes. So the indexed file organization, what happens is either we're storing the records in a file, either sequentially or non-sequentially, really doesn't matter, and then we're going to have an index that allows software, like the database management system, to locate individual records. So now what's an index? We haven't heard that term. Maybe we heard it in a previous lecture, but an index is a table or other data structure used to determine the location of records that satisfy some condition, right? So if I'm looking for a particular student record and I have their social security number, I'm going to look up the social security number in a table called an index, or another data structure. Maybe it's just a list of some kind. And what I'm going to do is I'm going to look up in the index the social security number, and then that index is then going to have attached to it. So think of an index as a two-column table. The data that's being indexed or sorted, more than likely a primary key. So as you can see in the next bullet, primary keys are automatically indexed. So if I take my primary keys and I put them in an index, what's also in the index is literally the location on disk, the disk address of where that record is stored on disk. So let's take a look at what that looks like. And again, there are other fields can be indexed. We'll talk more about that in another lecture. But so here we've got a key called flyers, right? And we're looking for flyers. So what happens is we go to an index, and the index is broken up, and again, this is speed of retrieval. This is what's sometimes known as a B tree. This is a tree search. So what happens is, and it's funny, one of the better attributes of a tree is that it's short and fat, like a bush. So it really should be a bush search, but they call it a tree search. And what happens is you have different levels. So the average time to find a desired record, as you can see in red on the bottom, is the depth of the tree. So in this case, the tree is 3 levels deep. We have our top level, which is made of FPZ. So anything prior and up to F has a pointer, and that's what those arrow lines are. So here's where we're getting into pointers in the index. So I've got a file, right? So what's on top is that file, and that file has indexes for everything to get you from anything that's before F, anything before P, anything before Z, and after P, right? In this case, I'm looking for flyers. So flyers, I go to my first file, and it has an index, and it tells me, and it has a pointer that says, okay, I know the next level that you need to go to. So it sends you to the next level, and then when you go to the next level and you actually search, that search will point you to an address on disk for the small segment of data that actually has the records that you're looking for. So when you see the space in between B and D, that has aces and Boilermakers. And then the space after D points to indexed information associated with devils. So these are all, you can think of these as being partitioned, if that helps. So these are all teeny-weeny horizontal partitions put out there on disk, and then there are pointers set up to look for these. So now this stops me from having to do a full table scan, right? So now if I'm looking for flyers, I use the indexes, and in this tree search, my search is only 3. This is the old divide and conquer methodology. So if I break things down into smaller pieces, in this case like a partition, I can find my data faster, so my retrieval time is very, very quick. But realize that these indexes have to be maintained. So as I have, you know, if I turn out to have 5 or 6 teams that start with H, for instance, I'm going to overload that little box at the bottom that has Hawkeyes and Hoosiers in it. I'm going to have to explode that. I'm going to go into different other segments of data, and then all that needs to be maintained. You know, so we may have to make the second row wider with more files and more indexes associated with it. Things can get more complicated. So there's speed of retrieval, and then there's the maintenance of these indexes. And that is the end of my video lecture on indexed file organizations.